A doctor doesn't ask what hurts. A doctor asks for symptoms and patterns. Because symptoms lie when you read them in isolation. Pain in the left arm means nothing by itself. But pain in the left arm, combined with tightness in the chest, combined with shortness of breath, that's a pattern. That's a diagnosis. Your house works exactly the same way. It has symptoms. 5 of them. And most owners, when they notice one, go buy a solution for that one symptom and never understand why the problem keeps coming back. Today we change that. We're going to go through the 5 symptoms one by one. We're going to explain why each one happens. And then, at the end, we're going to show you something that will make everything click into place. Because all 5 share one root cause. One disease. 5 faces. Let's start. Symptom 1. Condensation in unexpected places. Not on the bathroom mirror after a shower. Not on a cold glass of water in summer. Those are normal. I'm talking about condensation on the inside of your exterior walls, on the underside of your floor joists, on a windowsill, in a room that's heated. People see this and they immediately think, humidity problem. So they go buy a dehumidifier. They run it. The condensation comes back in a week. Here's what's actually happening. Condensation forms when warm, moist air meets a surface cold enough to drop below the dew point. That process is physics, and it cannot be stopped by drying the air alone, if the cold surface is still there. What creates those cold surfaces inside a heated building? Gaps in the thermal envelope. When there's a break in your insulation layer, cold from outside conducts through the structure. The wall framing becomes cold. The rim joist becomes cold. The floor deck becomes cold. And when the warm interior air touches those surfaces, the moisture in that air condenses right there. The dehumidifier pulls moisture out of the center of the room. But air movement in the house continuously brings new humid air to those cold surfaces, and the process repeats. The real fix is not drying the air. The real fix is eliminating the cold surface. That means sealing the gap in the thermal envelope so those structural elements stop being thermal bridges to the outside. One symptom. One root. Symptom 2. Cold floors over a heated basement. This one confuses people deeply because it feels like the heat isn't working. The basement is warm. The furnace is running, but step out of bed in the morning and the floor feels like the middle of January. Here's the diagnosis. The floor between your living space and your basement is where the thermal boundary should be. That floor assembly, joists, subfloor, finish floor, needs to be the point of separation between inside temperature and outside conditions. But if the insulation in that assembly is incomplete, or missing, or compressed, or not air-sealed at the rim joists, then that boundary disappears. And here's the counterintuitive part. A heated basement doesn't solve this, because the basement might be 65 degrees Fahrenheit, and the living space might be 70 degrees Fahrenheit, but if cold outside air is infiltrating through the rim joists and the sill plate, which it almost certainly is, then that cold air moves along the floor assembly from the perimeter inward. The surface temperature of your floor drops, even when the air above it is warm. You feel it most first thing in the morning, because overnight, the infiltration has been running for 8 hours uninterrupted. The rug doesn't fix this. The thicker socks don't fix this. A space heater near the floor masks it temporarily. The fix is air sealing the rim joists and ensuring continuous insulation in the floor assembly from perimeter to perimeter, with no breaks. Symptom 3. Rooms that overshoot the thermostat by 4 to 6 degrees. You set the thermostat to 70. The dining room reads 76. The hallway reads 68. The bedroom reads 73. You adjust the vents. You balance the dampers. You call the HVAC tech, and he tells you the system is working fine. He's right. The system is working fine. The problem isn't the HVAC. When different rooms in the same house have different temperatures, without clear explanation from solar exposure or different thermostat zones, that variation is a map of your envelope failures. The rooms that run hot are gaining heat from outside faster than the system can remove it. That means their envelope is under-insulated or has air leakage that's allowing solar-heated air from the attic or wall cavity to enter the conditioned space. The rooms that run cold are losing heat faster than the system can replace it. Same cause, different direction. Envelope breaks are allowing conditioned air out and cold air in. The thermostat measures 1 point in one room, but a house with a failing envelope has 10 different thermal zones fighting each other, while the HVAC system runs in circles trying to satisfy a single sensor. This is why bigger equipment doesn't solve the problem. A bigger furnace in a leaky envelope is like a faster faucet in a bathtub with a hole in the bottom. The house with a continuous, sealed envelope has rooms within 1 degree of each other. The thermostat works. The system cycles normally. No hot spots. No cold spots. 1 envelope. 1 temperature. Symptom 4. Persistent dust on certain wall edges. This one is the most invisible of the 5. And it's the one that tells you the most precise information about where your envelope is failing. Walk through your house right now. Look at the baseboards, especially in corners. Look at the top plates where walls meet ceilings. Look at the trim around your electrical outlets on exterior walls. If you see a consistent line of gray-brown dust that reappears no matter how often you clean, that is not a housekeeping issue. That is a diagnostic marker. It's called thermal bypass dust marking, and it happens when air moves through gaps in the building assembly. As air travels through a crack or gap in the structure, it carries fine particulates with it. Those particles deposit on the first fibrous surface they contact: insulation, drywall, paint. And over time, they create a visible stain that maps the path of the air leak exactly. This is so reliable that building scientists call it ghosting and use it as a low-tech diagnostic tool before even running a blower door test. The location of the ghosting tells you the location of the bypass. Top plate staining means bypass between the wall cavity and the attic. Baseboard staining on exterior walls means bypass at the sill plate or rim joist. Outlet staining means the electrical box is providing a direct path through the wall cavity to outside. Each of those locations is a point where the air barrier has failed. And every cubic foot of air that moves through those gaps is conditioned air you paid to heat or cool, escaping to outside. This symptom is your house leaving you a map in dust on your walls, showing you exactly where the problem is. Symptom 5. Your HVAC running 20% more than an identical neighbor's system. This one requires context, but it's the most financially revealing symptom of the 5. Maybe you've compared utility bills with a neighbor. Maybe you've looked at energy benchmarking data. Maybe you just have a sense that your system runs more than it should for the size of the house. 20% more runtime on the same equipment, in the same climate, in roughly the same size house, means one thing. Your envelope is doing less work. so the mechanical system is compensating. Think of the thermal envelope as the passive layer of your home's energy system. A well-sealed, continuously insulated envelope reduces the rate at which heat enters in summer and escapes in winter. The slower that rate, the less the HVAC has to run to maintain set point. When the envelope has gaps, thermal bridges, and air leakage, the heat transfer rate increases. The house loses conditioned air faster. The HVAC kicks on more frequently, or runs longer cycles to keep up. 20% more runtime is not a small inefficiency over a full heating and cooling season in a cabin or small home. That's hundreds of dollars in energy cost, compounding every year. And here's the harder math. If you replace a 15-year-old HVAC system without fixing the envelope, the new system will run 20% more than your neighbor's new system within the first season, because the load hasn't changed. The envelope is still leaking. You've spent thousands and solved nothing. The table, where symptoms cluster. Here's where the diagnosis becomes powerful. Each of these 5 symptoms can occur in isolation due to a specific local failure. Condensation from a single bad window seal. Cold floor from missing rim joist insulation in one corner. A dusty baseboard from one open top plate. When you see multiple symptoms in the same room or on the same face of the house, you're not looking at multiple problems. You're looking at a zone of envelope failure. The north face of a cabin with condensation on the wall A&D, cold floor A&D, dusty baseboard trim, has a continuous failure in the air and thermal barrier on that entire wall assembly. All 3 symptoms are the same failure, showing up in 3 different ways. The room above the garage that's always 4 degrees too hot in summer A&D has the dusty ceiling trim A&D, causes the HVAC to run longer, has a failed air barrier between the garage ceiling and the living space above. 3 symptoms. 1 location. 1 fix. When you map your 5 symptoms geographically across your floor plan, you stop treating 5 problems and you start treating 1 zone. This is the shift from reactive maintenance to structural diagnosis. The physical exam. 15 minutes. No equipment required. You don't need a blower door. You don't need a thermal camera. You need 15 minutes and a quiet house. Close all windows and doors. Turn off the HVAC fan. Light an incense stick, or use a smoke pencil if you have one. Start at the perimeter. Move the smoke along the sill plate at the base of every exterior wall. Watch for pull. The smoke bending toward the wall means air is being drawn in. Move to the top plates at the ceiling line. Move to every electrical outlet and switch on exterior walls. Check the rim joists in the basement or the floor edge in a crawl space. Mark every location where the smoke moves. Write it down or photograph it. Then cross-reference with your symptom map. Are the smoke movement locations in the same zones as your condensation, your dust marks, your cold floors? If yes, you've just identified your envelope failure zones without a single piece of professional equipment. 3 fixes, all 5 symptoms, 1 zone at a time. The treatment for a failing thermal envelope reduces to 3 interventions. First, air sealing. Close the gaps. Rim joists with spray foam or rigid foam and acoustic sealant. Top plates with sealant. Electrical penetrations with foam backer and cover plate. This eliminates the bypass airflow that causes dust marking, condensation, infiltration losses, and runtime increases. Second, thermal continuity. Ensure the insulation layer has no interruptions. This means addressing compressed batts, missing sections, or thermal bridges at framing members. In most cabin or small home retrofits, this means adding continuous rigid insulation to the exterior face of the wall or to the interior face of the rim joist. Third, vapor management. Once air sealing is complete, verify that the vapor profile of your assembly is correct for your climate zone. A sealed assembly without correct vapor management can trap moisture inside the wall. This is the one step where a blower door pro's assessment is worth the cost. They can verify tightness and flag any vapor reversal risk before it becomes a rot problem. When to call a pro. When to go alone. For air sealing the rim joists, top plates, and electrical penetrations, you can do this yourself. The materials cost under $200 for a standard cabin. The technique is not complex. The payoff is immediate. For verifying thermal continuity in an existing assembly, a thermal camera rental for a weekend will show you exactly where the breaks are. Some extension offices and utility programs offer this at no cost. For a blower door test, call a pro when you have reason to believe you've achieved meaningful tightness and want to verify it before closing up a renovation, or when you're buying a house and want to know its actual infiltration rate before making an offer. The blower door test costs between $200 and $500 and gives you a number, ACH 50, that tells you exactly how tight your envelope is compared to code minimum and compared to high-performance targets. If your house scores above 10 ACH 50, your envelope is failing. If it scores under 3, you're in good shape. Under 1, you have a high-performance building. The cost of treating 5 symptoms independently in a typical cabin easily exceeds $3,000. A dehumidifier for the condensation, weather stripping for the drafts, rugs for the cold floors, a larger HVAC for the runtime, cleaning for the dust marks, which keeps coming back. $3,000, and the symptoms are still there. The cost of treating the envelope, air sealing the rim joists, topping up insulation continuity, sealing the top plates, rarely exceeds $800 in materials for a cabin-scale building and eliminates all 5 symptoms because it treats the one disease. 5 problems. 1 disease. Treating the symptoms keeps you sick. Treating the envelope heals the house.